on the previous page we saw what happens if a rectangle is actually a parallelogram and it's skewed. But if it is perfectly square and has 90-degree angles in all four corners, then a diagonal is the hypotenuse of a right triangle. And the right triangle is half of the rectangle. So we can apply the Pythagorean theorem to find the length of the hypotenuse, which is the diagonal. Instead of writing a squared plus b squared equals c squared, I wrote d squared equals l squared plus w squared. Here it is. The Pythagorean theorem refers to right triangles. You may have seen a squared plus b squared equals c squared. In that case, c is the hypotenuse. In our case, d is the hypotenuse, d for diagonal. So again, where the c squared would be by itself, we have a d squared by itself on one side of the Pythagorean theorem equation. Let's draw a rectangle, and then we'll label it a 12 by 16 rectangle and draw one diagonal in that rectangle. So here is my rectangle, and I've labeled the width and the length, and I drew in a diagonal, and here's my right angle. So I'm trying to find how long the hypotenuse is, and here is my formula to fill in for the Pythagorean theorem. So you're using this format. D is what you don't know. L gets replaced by 16. W gets replaced by 12. So d squared is equal to 16 times 16 is 256. 12 times 12 is 144. So just again a reminder that we can do 12 squared and 16 squared, and then we can take 144 plus 256, which is nice. It turns out to be 400. So d squared is equal to 400. Now we just need to know what the value of d is. So what times itself is equal to 400. So just a reminder, we are looking for a number times a number. 16 times 16 is 256. 17 times 17 is 289. 18 times 18, 324. Getting closer, 19 times 19, 361, 20 times 20, there it is, it's 400. So the diagonal should be 400, I'm sorry, the diagonal should be 20 because 20 times 20 is 400. So I'm going to show you square roots in the next little box. So d squared equals 16 means we're looking for a number. What times what is 16? The answer is 4. 4 times 4 is 16. And we can find that if we don't know it by finding the square root of 16. So I'm going to clear this. And again, 4 times 4 is 16. Let me clear all of it. And then we can say, okay, what is the square root of 16? So in this calculator, we press the square root button first, and then we type 16 and press enter, and the answer is 4. What about the square root of 100 or the square root of 500? Square root of 100 is 10, because 10 times 10 is 100. The square root of 500 is not going to be a clean number. It's going to be what I call a yucky decimal, 0.36, blah, 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 keeps going. So that's okay. We can round to a couple of decimal places as needed. So here the answer would be 10. And here the answer would be 22.5. 22.36. And you can keep going down the line here. So if d times d is 100, then d must be 10, because 10 times 10 is 100. D squared is 500, so I'm like, okay, what's the square root of 500? I get 22.36, and then I can check 22.36 times 22.36, and that basically gives me 400 back. So it's very, very close. Close enough. If d squared is 80, well, what's the square root of 80? I want to find out what d is. 8.94. So obviously I'm losing a little accuracy if I say 8.94, but I'm close. Times 8.94. There it is, 79.92. Close enough, almost 80. And so on. So that's how square roots work. They're helping us to figure out what times itself would give you the number. So I challenge you to take the square root of your age. For somebody who is 21, let's find the square root of 21. Okay, so the square root of your age is 4.58. That means that 4.58 times 4.58, whoops, will give you your age. And it basically works. I don't know why you would take the square root of your age, but there you go.